In this chapter, we're going to look at inverse trigonometric functions. In order to get an idea what it is about, let us look at a completely different example. We're given a square with side length s is 5 centimeters and we want to find its area. To find the area, we have to take the square of the side length and we get 25 centimeters squared. Now, in a second example, we're given the area of a square and we want to find the length of the side. To find the length of the side, we have to take the square root of the area and we get 7 centimeters. So what happens when we're given the side S and we want to find the area A, we take the square. When we're given the area A and we want to find the side S, we take the root. So we invert the direction, then the square root is the inverse function of the square. Now let us compare this with the trigonometric functions. For these we are given an angle and the function results in the corresponding ratio. For example, we know the angle theta, we're interested in the ratio opposite divided by hypotenuse, so what do we have to do? We have to take the sine of theta. For the inverse trigonometric functions, we are given a ratio and the inverse trigonometric function yields then the angle. These inverse trigonometric functions are called arccos functions, so we have arcsine, arccosine and arctangent. Note that they are often also written as sine to the power of -1 or cosine to the power of -1 or tangent to the power of -1. Especially on the calculator you'll find them with this naming. Nevertheless, we will not use this naming. So when we're given the ratio opposite divided by hypotenuse and we want to find theta, we have to apply arcsine. With sine, we get from the theta to the ratio, with arcsine from the ratio to the angle. Let us look at this triangle here. Sine of theta is by definition b divided by c, and so theta is arcsine of b divided by c. Try to fill in cosine and tangent of theta. Stop the film, and here you see the results. Now let us look at a specific triangle where b is 3, a is 4, and using Pythagoras we get that c is 5. So sine of theta is by definition 3 divided by 5, and theta is the arcsine of 3 divided by 5, and using the calculator we get approximately 36.9 degrees. Here is how to use the calculator. So we need the sine to the power of -1 of the 3 divided by 5, and we get 36.9, which means 36.9 degrees. Now solve these two lines on your own, stop the film, and here comes the results. And obviously if you've done it correctly, you'll get every time 36.9 degrees, since it's always the same angle theta here. Let us now apply this in a few examples. In example 1, side A and C are given and we're looking for the angle beta. C is the hypotenuse, A is the adjacent, so it is the cosine we're talking about. Cosine of beta is A divided by C, so beta is arccosine of A divided by C, and we get arccosine of 2 divided by 7, which is approximately 73.4 degrees. In example 2, the side C and the angle beta are given and we're looking for the side A. We're looking for a side, so we need the original trigonometric function, not the inverse one. C is the hypotenuse, A is the adjacent, so again we need the cosine. So we get cosine of beta is A divided by C like above, and solving this for A, we have to multiply by C and we switch sides. We get A equals C times cosine of beta. Let us now insert the values and we get approximately 3.83 centimeters. In example 3, the sides A and B are given and we're looking for the angle alpha. Looking for an angle means we need the inverse trigonometric functions. B is the adjacent, A is the opposite, so the ratio is the tangent. So tangent of alpha is A divided by B, and we get alpha is hence arctangent of A divided by B. Inserting the values, we get arctangent of 1.5 divided by 4, and using the calculator, this yields for alpha 20.6 degrees.